Next chapter, that is chapter number 6, soils. Soil is nothing but it is the loose matter which is available on the surface of the earth. It is a mixture of rock debris and organic materials which develop on the earth over a period of time. Now, these are important. The factors that affect the formation of soil. See, you have important term called pedology. Pedology is nothing but study of soils, and you have the process of pedogenesis. Pedogenesis is nothing but formation of soil or soil forming process. The factors that affect pedogenesis, first one relief, second one parent material, third one climate, fourth one vegetation, and other life forms including human activities. For example, if you have some igneous rock here, on weathering and erosion of this igneous rock, from that you may get black soils. So in this manner, parent rock material determines the type of soil. Next, relief. For example, when you go to the mountainous regions, you have very high rainfall, okay? Because of that, you can find some different kind of soils. And next, climate. For example, dry climate, wet climate, or the areas which experience very high rainfall and the areas which experience very low rainfall with a high temperature, okay? So accordingly, even the soil type would change, okay? We, human beings, through our activities like mining, shifting cultivation, agriculture, etc., we involve or interfere with this soil formation or pedogenesis process. Next, you have another concept called soil profile. Soil profile is nothing but the vertical arrangement of the soil layers, okay? Generally, in NCERT, three horizons are given. Horizon A, which is considered as the topmost zone. Next to horizon B, which is the transition zone. And horizon C, which is the deeper or innermost horizon. A, B, C, okay? If you can elaborate on this, the uppermost part or uppermost layer is considered as O layer, which is characterized by humus. Humus is nothing but dead organic matter. After the death of plants and animals, including human beings, we have this decomposed organic matter. We call it as humus. And next layer is A layer. Next layer is E layer. Next B layer. Next C layer. Next R layer. Okay. This is the detailed structure of the soil profile. This C layer, it is parent rock, and R layer, it is nothing but bedrock. Okay. Uppermost layer is O layer, where you have the humus and the loose sand matter, and after that you have topmost layer, that is A, after O layer. Next you have E layer and B layer. See, when you have the rainfall, what happens? For example, if this is soil and you have the rainfall, some water will be percolated into deep layers of the earth. Some water is flowing on the ground and remaining water is getting percolated into the deep layers of the earth, and it will be settled as groundwater. Okay, that's how groundwater table is formed. Now, during this process of percolation, this percolating water will drag or wash away all the minerals which are lying in the upper layers of soil into the deep layers. Okay, now point is E layer, which experiences the exit of the minerals. Minerals from the E layer are generally washed away into the B layer. So B layer is experiencing the deposition of the minerals which are coming from the E layer. Okay, this is the detailed structure of soil profile. But in NCERT, only three horizons are given: A, B, and C. Try to remember this. Next, classification of soils. Okay, in ancient times, soils are generally considered categorized into two types: Urvara and Usara or Asara. Urvara means fertile soils. Asara means sterile soils. Okay, so these are useful for cultivation or agriculture, and the second type is not fit for cultivation. Next, based on the texture, soils are categorized into three types. Instead of texture, simpler term, we can say that based on the diameter of the sand particle. If the diameter of the sand particle is more, then you can call it as sandy soils. If the diameter is medium, then you can call it as silty soils. And if it is very fine-tuned material, or the diameter is very small, then you can call it as clay. Okay, so the clay soils are generally found in the lower course of the river, and in the upper course of the river you can find sandy soils, and in the middle course you can find silty soils. Okay, now if you can find the sandy, silty and clayey soils in equal proportion, if their proportion is very equal, then you can call them as loam soils or loamy soils. Okay, these loam soils, they are highly suitable or favorable for wheat cultivation. Very important previous question. Just try to remember this map. And the US State Department of Agriculture, it has given some classification or soil taxonomy of India. You have insectizoles, entizoles, alphizoles, vertizoles, aridizoles, altizoles, mollizoles, etc. Okay, and apart from that, Indian Council of Agricultural Research, it has given eightfold classification of Indian soils. According to ICAR, we have 8 types of soils in India. You just have a look. The first one, alluvial soils. Second one, black soils. Third, red and yellow soils. Next, fourth, laterite soils. Fifth, arid soils. Sixth, saline soils. Seventh, peaty soils or peat soils. And eighth, forest soils. Okay, in every soil we look for some important nutrients. Next, other significant characteristic, and crops that are generally grown in that kind of soils. First, alluvial soils. Always remember, wherever you have the scope for river flow, in that area you can find alluvial soils. For example, Ganga River Basin, Godavari River Basin, Krishna River Basin. Okay, so that is why the largest soil variety in India is of alluvial soils. Okay, now don't try to by heart the states. Okay, just have these important tips in your mind so that you can easily eliminate the options. Now, alluvial soils, they are rich in potash but poor in phosphorus. Okay, and you have Bangar and Kadar. I have already explained what is meant by Bangar and what is meant by Kadar. Bangar is older alluvial, Kadar is newer alluvial. Okay, and Kadar, it is fertile, unlike Bangar, which is not that much fertile. Okay, and Bangar is known for dark sand material, Kadar is known for light colored sand material. Okay, next you have cankers. Cankers, nothing but these are the calcareous concretions. Okay, you have the more calcium content. Alluvial soils, they are generally support intense cultivation, especially crops like rice, okay, sugarcane, etc. Next, black soils. Black soils are found in the areas where you have the scope for volcanic eruptions. I told you that the Deccan Plateau region of India experienced fissure type of volcanic eruption. As a result, the Deccan Plateau region is known for black soils, and black soils, they offer suitable conditions for cotton cultivation. So the Deccan Plateau region is known for the cotton cultivation. For example, states like Maharashtra, Gujarat. In fact, Maharashtra and Gujarat, these are the largest producers of cotton in India. Why? Because they are endowed with black soils. Now, you just go through this map, major soil types. Black soils are also called riggers. A rigger is nothing but, it's a Latin term which means cotton, or simply black cotton soils. And another significant characteristic of black soils self-flowing. Generally, during rainy season, when you have the rainfall, what happens? The black soils, they become sticky. They fuse together whenever you have the rainfall. And during dry season, as shown in the map, you have the expansion or the development or formation of fractures, okay, or cracks. So during dry season, they are expanding, and during the rainy season, they are coming together. Expansion and contraction, expansion and contraction. In this manner, they are flowing themselves on their own. That is why they are called as self-flowing soils. Okay. Next, they are rich in lime, iron, magnesium, and alumina. They also contain potash, but they are poor in terms of phosphorus, nitrogen, and organic matter. Okay. Next, red and yellow soils. The difference between red soils and yellow soils. First of all, why they are called red soils? Because they contain iron. When you have the high iron content, automatically that will impact red color. For example, you have Mars. Mars is called red planet. Why? Because of the iron rich surface. Okay. Now, then what is meant by yellow soils? If you add some water to red soils, then the color of the red soils will be yellow. So you can simply say that red soils are called yellow soils in their hydrated form. When you add water to red soils, they become yellow in terms of color. Okay. And this red color is due to the iron content. I have discussed this. They are poor in nitrogen, phosphorus, and humus. Humus I have already explained. It is nothing but dead organic matter. Okay. Next, when it comes to the important crops, red soils, they are highly suitable for pulses, the cultivation of pulses. Red soils are generally found in the states like Madhya Pradesh and Chhattisgarh. Madhya Pradesh, it is known for the significant or the wider distribution of red soils. That is why Madhya Pradesh is the largest producer of pulses in India. Why? Because it is endowed with the red soils. Okay. So this is how you can interlink the soil type, climatic type, and the crop variety. Okay. Next, laterite soils. Laterite soils are generally found in the areas where you have the high rainfall and high temperature. When you have this combination in those areas, you can find laterites. Okay. Later is a Latin term which means brick. Why they are called brick soils? Because they are used in the manufacturing of bricks. Bricks are used in construction. Okay, for house construction purpose. Next, yes, they are seen in the areas with a high temperature and high rainfall, and they are rich in iron oxide and aluminium oxide. Okay. Apart from this, you cannot find any other lighter minerals. Why? Because when you have the high rainfall or heavy rainfall, you have the intense percolation. If you have the intense percolation, automatically majority of the minerals will be dragged downwards, okay, leaving behind only heavier minerals. Okay. So these iron oxide and aluminium, they are very heavy. That is why they are remaining there in the upper portion. Okay. So laterites are generally rich in terms of iron oxide and aluminium oxide, but poor in organic matter, nitrogen, phosphorus, calcium. Okay. And in their original form, these laterites are not suitable for cultivation. They do not support cultivation, but with the application of fertilizers, by using some fertilizers, you can go for cultivation in these soils. Okay. And in India, the Western Ghats region and the northeastern part of India, especially Meghalaya, so these are known for very high temperature and high rainfall. So that is why laterites are seen in these states only. Next, arid soils. Arid soils are generally seen in the dry areas like Rajasthan, etc. Okay, they are sandy in structure and they are saline in nature. Why they are saline? Because you have the high temperature. When you have the high temperature and low rainfall, evaporation rate would be greater. If you have the more evaporation rate, automatically you can expect the more concentration of salts in the upper layers. Okay. So the desert soils or arid soils, they are sandy in nature. At the same time, they are saline in nature. They lack moisture and humus. You cannot find the humus at all. Why? Because humus is nothing but what? Dead organic matter, dead plant and dead plant and animal species carcasses. Okay, so when you have low rainfall and high temperature, you cannot expect vegetation at all. As a result, biodiversity would be very low. If that is the case, scope for humus formation would be very low. So that is why arid soils are poor in humus. Nitrogen is also insufficient and phosphate is quite normal. Okay. You have the canker layers. Canker nothing but calcareous congregations. I just discussed just now. Arid soils are generally developed, widely seen in the western part of Rajasthan. Okay. Next, saline soils. They are also called Usara soils. They contain large proportion of sodium, potassium, and magnesium, and you can find them from sandy to loamy structures. They are lack or poor in nitrogen and calcium. This point is important. Excessive irrigation with the dry conditions promotes the capillary action, resulting in the increased salt concentration. For example, you have some dry area. Okay, dry area in the sense where you do not have the scope for the flow of rivers. For suppose artificially, if you are providing some kind of irrigation to this area, you are providing irrigation to the area where you have high temperature, which means that high evaporation. As a result, what will happen? Because of this increased rate of evaporation, the capillary action is nothing but you have the upward movement of salts from the lower layers of the earth towards the upper layer because of this high evaporation. Okay, so the salt concentration would be increased. All right, and if you want to go for some kind of cultivation, first of all you have to reduce the salinity levels. For that purpose, you can add gypsum. Okay, and by providing some kind of irrigation, you can go for cultivation, especially millets. You can grow millets which require low rainfall and they can survive in high temperature. Okay. Next, peaty soils. They are found in the areas with a heavy rainfall and high humidity. Now, humus content is more. They are alkaline in nature. They can be found in the northern part of Bihar, southern part of Uttarakhand, coastal areas of West Bengal, Odisha, and Tamil Nadu. Forest soils, also called mountain soils, they are generally seen in the mountainous regions. They can be loamy or silty, and humus content would be high. Yes. Next, soil degradation. Soil degradation is nothing but decline in the soil fertility. How that will happen? Because of the usage of chemical fertilizers. When you go for high application of chemical fertilizers, automatically that will degrade the soil health. Instead of that, you can prefer organic manures or biofertilizers. Okay, and you have the concept of soil erosion, soil getting eroded. When you clear up the natural vegetation, what will happen? When you have the natural vegetation, it will be able to reduce the flow of water. Okay, but when you clear off the natural vegetation, nothing but deforestation, automatically water velocity would be increased. If the increased water flows with the increased velocity, the soil erosion rate would be greater. Okay, so deforestation is responsible for soil erosion. In other words, you can say that soil degradation. Okay, next you have gully erosion. See, this is the perfect example. Ravines or gully erosion. When you have the flow of water with increased velocity, that will lead to the formation of some kind of gullies. Okay, a region with a large number of deep gullies or ravines, then it is called as badland topography, which is generally seen in the Chambal area. I have clearly explained this while doing with the drainage system. Okay, so Chambal area is known for badland topography. If that is the case, you cannot go for cultivation. It is not suitable for cultivation of human settlements, etc. Next, how to conserve the soil. Conservation of soil is nothing but you have to confront the deforestation by promoting afforestation, going for planting more number of trees. Okay, and checking overgrazing shifting cultivation, promoting contour bunding, okay, terrace cultivation, and going for controlled grazing, and even crop rotation, mixed farming, etc. These are the methods through which you can promote the soil health, or you can conserve the soils. This is with your the sixth chapter in unit 3. Okay, thank you.